A missile tears across the night sky above the Red Sea, its guidance system locked with unsettling certainty. It isn't hunting randomly. U.S. Navy warship, a vessel layered with some of the most advanced defensive systems ever engineered. Billions of dollars in radar arrays, interceptors, electronic warfare suites, and close-in weapons stand between that ship and destruction. And yet the missile flies as if it knows exactly where that ship will be. That's the part that should unsettle you. The fighters launching these weapons from Yemen's mountains were, until recently, reliant on aging Soviet-era hardware and refurbished Iranian stockpiles. They were not known for precision strike capability against moving naval targets. Tracking a warship in one of the busiest, most contested waterways on Earth requires more than courage and borrowed missiles. It requires data, real-time, reliable, and precise. So how are they doing it? The answer may not be on the ground at all. It may be orbiting thousands of miles above it. Above the Red Sea, satellites sweep silently across the planet, mapping ships, ports, coastlines, and traffic patterns. Public discussion has focused heavily on one Chinese space initiative often described as Beijing's answer to Western satellite internet networks. But that narrative misses the mark. The system drawing scrutiny in Washington isn't an internet constellation at all. It's something quieter, less flashy, and arguably more consequential. A commercial Earth observation network capable of photographing nearly any location on Earth with striking clarity. Unlike broadband satellites designed to deliver connectivity, Earth imaging satellites are built to watch. They capture detailed optical imagery, sometimes sharp enough to distinguish individual vehicles or identify ship classes. When dozens or hundreds of these satellites operate together, revisit times shrink. A location can be photographed repeatedly within short intervals, creating something close to persistent monitoring. In practical terms, that means a commander on the ground doesn't need aircraft reconnaissance or naval patrols to know what's moving through a choke point like the Bab el-Mandeb Strait. Updated imagery can reveal vessel positions, headings, and formation patterns. For anti-ship missile operators, that difference is enormous. Hitting a moving target at sea requires more than a rough estimate. It requires prediction, and prediction requires data. Some of these satellites are capable of capturing not just still images, but short video sequences. That matters. A still frame shows you where something was. Video begins to show you how it moves. For a missile that may take minutes to reach its target, understanding speed and trajectory is critical. The more accurate the tracking data, the smaller the margin for error. Now, what makes this even more complex is the nature of China's aerospace ecosystem. Many companies that market themselves as commercial providers of agricultural imaging, environmental monitoring, or urban planning analytics also operate within a broader national framework that encourages integration between civilian and defense sectors. This approach, often described as military-civil fusion, means technological advances rarely stay confined to one lane. The allegations surfacing in Washington suggest that satellite imagery from such systems has been used to assist targeting operations in the Red Sea. Beijing denies direct involvement. But the line between commercial service and strategic leverage can be thin, especially when dual-use technologies are involved. Meanwhile, the impact on maritime trade has been undeniable. Dozens of vessels have been attacked since late 2023. Insurance rates for transiting the region have surged. Major shipping companies have rerouted around southern Africa, adding time, fuel costs, and strain to already fragile supply chains. The Suez Canal, one of the world's most important trade arteries, has seen traffic fluctuations as security concerns mount. And here's where the geopolitical chessboard becomes clearer. Every American destroyer deployed to defend commercial shipping is a destroyer not deployed elsewhere. Every interceptor missile fired in the Red Sea is one that must be replaced. Sustained operations wear down crews, consume stockpiles, and demand logistical support. For rivals watching from afar, this is valuable information. Each engagement reveals tactics, defensive responses, and operational rhythms. There is another dimension, components. Interdictions over the past several years have revealed shipments of drone parts, propulsion systems, electronics, and raw materials flowing through complex supply chains. These aren't always complete weapons systems. They are pieces, propellers, circuit boards, composite materials, guidance components, items that can serve civilian markets, but also be assembled into military platforms. The ambiguity provides insulation. A propeller can power a hobby aircraft. It can also power a long-range drone. This is modern proxy competition. It rarely involves uniformed troops crossing borders. Instead, it flows through data streams, satellite passes, online marketplaces, shell companies, and plausible deniability. No official declaration, no formal alliance, just capability quietly transferred, tested, and refined. The Red Sea has become more than a shipping crisis. It is a laboratory. Each missile launch tests detection systems. Each interception measures defensive thresholds. Each near miss reveals something about reaction time and sensor coverage. And somewhere above it all, satellites continue their silent orbit, watching ships glide through narrow waters, recording movement patterns, and feeding an information ecosystem that has become just as consequential as any missile. This isn't just about one militia group gaining unexpected accuracy. It's about how space-based observation, commercial technology, and geopolitical rivalry intersect in ways that blur the line between peace and conflict. The missile streaking through the night is only the visible part of the story. The real battlefield may be the data guiding it. The pattern doesn't stop at small drone parts. When the U.S. Treasury imposed sanctions in late 2024, officials didn't describe massive weapons transfers. They described something subtler. Companies exporting dual-use electronics, precision components, and industrial materials that can serve civilian markets but also form the backbone of advanced missile and drone systems. One firm was identified as supplying large quantities of specialized electronics suitable for missile guidance assemblies. Another exported significant volumes of components that, while commercially available, were later traced to weapons manufacturing pipelines linked to Houthi forces. These weren't container ships full of finished missiles. They were shipments of circuit boards, navigation modules, propulsion elements, and control systems. The building blocks needed to assemble increasingly capable weapons locally. That distinction matters. Shipping complete missiles is obvious. Shipping parts is deniable, and then there's chemistry. In early 2025, tracking data revealed that Iranian vessels transported more than 1,000 tons of sodium perchlorate from China to Iran's southern port facilities. Sodium perchlorate is widely used in industry, but it is also a critical oxidizer in solid rocket fuel. Iranian authorities dismissed suggestions that the shipment was linked to missile production. Private maritime security analysts, however, confirmed the cargo transfer. Within months, a major explosion struck the same port area. Officials described it as unrelated to weapons activity. But the timing, coming amid heightened scrutiny of supply chains feeding Houthi missile operations, fueled international suspicion. Individually, each event can be explained away. Together, they outline a triangular network. China supplies components, materials, and, allegedly, satellite-derived intelligence. Iran acts as the intermediary, providing weapon systems, engineering expertise, and operational training. The Houthis execute attacks that strain U.S. forces and disrupt Western-aligned trade routes. Each participant can claim limited involvement. Beijing describes commercial trade. Tehran frames its support as resistance assistance. The Houthis portray their campaign as ideological solidarity, yet the cumulative effect serves overlapping strategic goals. When confronted, the accused companies reject the allegations outright. Satellite operators deny providing targeting support. Chinese officials argue that they promote stability in the Red Sea and question whether sanctions, rather than diplomacy, are escalating tensions. Some analysts sympathetic to Beijing assert that commercial imaging satellites lack the refresh speed necessary for real-time missile guidance against moving naval targets. Technically, they have a point. No commercial satellite constellation is likely feeding live targeting coordinates directly into a missile mid-flight. Orbital mechanics, imaging intervals, and processing times make continuous real-time tracking extremely difficult. But that may not be the claim being made. Effective targeting doesn't require a satellite acting as a joystick. It requires pattern awareness. Imagine assembling a layered surveillance picture. Satellites provide recurring snapshots of ship positions across the Red Sea. Over time, those snapshots reveal patrol routes, transit speeds, anchorage habits, and operational rhythms. That data, potentially filtered through Iranian intelligence channels, builds a predictive model. Then local reconnaissance, including drones the Houthis demonstrably operate, fills in the final layer. Drones supply real-time confirmation, satellites supply strategic context. The result is not perfect tracking, it is probabilistic targeting, often good enough. From Beijing's perspective, the strategic logic is cold but clear. The Red Sea has become a cost imposition zone. Every U.S. destroyer deployed to defend shipping is a destroyer not positioned elsewhere. Every interceptor missile fired drains stockpiles that take years to replenish. Sustained operations strain crews, maintenance cycles, and budgets. Meanwhile, China expends no uniformed personnel, fires no missiles, and maintains diplomatic distance. The architecture is indirect by design. Commercial firms handle exports. Dual-use goods blur legal lines. Satellite imagery can be framed as civilian service. Iran acts as a buffer layer between supplier and shooter. It is difficult to retaliate cleanly against such a structure. Sanction one company and others emerge. Confront Beijing, and proof thresholds become politically sensitive. Release intelligence publicly, and sources may be compromised. Military retaliation has limits as well. Airstrikes can destroy stockpiles, launch sites, and command centers. They can eliminate fighters and disrupt operations. But as long as the underlying supply chains remain functional, components arriving, materials flowing, expertise circulating, capabilities regenerate. That regeneration cycle is the strategic challenge. Escalating further introduces additional risks. More aggressive maritime interdictions could mean direct confrontation with Iranian vessels. Broad sanctions on major Chinese firms could trigger economic retaliation. Cyber operations targeting satellite networks could open a domain where the United States itself is deeply dependent on commercial space infrastructure. And this crisis does not exist in a vacuum. It intersects with Iranian nuclear negotiations, Israel's security environment, the war in Gaza, and US-China strategic rivalry. Pressure applied in one arena affects leverage in another. Diplomatic channels intertwine with military signaling. Meanwhile, the Houthis have demonstrated growing reach. Attacks have extended beyond shipping lanes. Coordination with broader regional conflicts has increased. Weapon sophistication has evolved. Each step suggests access to better materials, improved engineering, and more refined targeting intelligence. Stepping back, the larger transformation becomes visible. This is not traditional proxy warfare in the Cold War sense. There are no large-scale troop deployments or overt weapons transfers stamped with national insignia. Instead, influence flows through data, components, commercial platforms, and layered intermediaries. It is a model of conflict built on ambiguity. Space plays a pivotal role in this shift. For decades, American dominance in satellite reconnaissance provided overwhelming informational advantage. That edge is narrowing as commercial constellations proliferate globally. High-resolution imagery, once the exclusive domain of governments, is increasingly accessible through private firms operating in regulatory gray zones. When civilian imaging systems can contribute, directly or indirectly, to military targeting, the boundary between commercial and combat erodes. That erosion raises uncomfortable questions. If satellite imagery aids a missile strike, is the satellite operator a combatant? If dual-use electronics enable drone production, where does civilian commerce end and military supply begin? If governments leverage commercial ecosystems for strategic gain while denying direct involvement, how do international norms adapt? The Red Sea may be remembered not only for disrupted shipping lanes, but for illustrating how space-based observation, globalized supply chains, and proxy actors can combine into a new template for geopolitical competition. No declarations of war, no formal alliances, just networks, technical, financial, and orbital, quietly reshaping the balance of power. And the satellites continue to pass overhead, every 90 minutes watching. These concerns grow sharper as China rapidly expands its presence in orbit. Project G60, the massive satellite internet constellation mentioned earlier, aims to place roughly 15,000 satellites into space by 2030. Officially, it is a communications network designed to rival Starlink. But the real significance may not lie in its stated purpose. It lies in the industrial ecosystem being built to support it. Factories in Shanghai capable of producing hundreds of satellites per year are not limited to manufacturing broadband platforms. Once that infrastructure exists, launch vehicles, assembly lines, ground stations, supply chains, it can be redirected. Earth observation satellites, signals intelligence platforms, experimental military payloads, all become easier to scale when the industrial base is already humming. China has even filed preliminary orbital registrations with international regulators that, if fully utilized, could support constellations numbering in the hundreds of thousands. Whether that number represents firm intent or strategic positioning, it signals ambition on a breathtaking scale. This expansion feeds into a larger strategic tension Washington has yet to resolve. The Cold War containment model doesn't neatly apply to China. The two economies are deeply interwoven. Supply chains cross borders, capital flows in both directions. Technology ecosystems overlap. At the same time, the assumption that economic integration would naturally produce political convergence has clearly fallen short. What remains is an uneasy coexistence, part cooperation, part rivalry, playing out simultaneously across trade, technology, military posture, and space. And in that gray space, proxy conflicts flourish. Some analysts argue that the Red Sea is a preview of future confrontation, not tanks crossing borders or formal declarations of war, but persistent friction through intermediaries, satellite data instead of soldiers, dual-use exports instead of arms shipments. Others believe Beijing is observing American responses closely, measuring reaction times, thresholds, and escalation tolerance, lessons that could matter profoundly in a Taiwan contingency. What's undeniable is that maritime security models built for earlier eras are straining under this new reality. Deploying destroyers and escorting shipping lanes addresses symptoms. It does not dismantle the global networks supplying the threat. The media confusion between Project G60 and Changguang's Earth observation constellation highlights something important. On paper, they are distinct programs. One communications-focused, the other imaging-focused. Strategically, however, they are components of a larger architecture, a comprehensive space ecosystem backed by state support and designed with dual-use flexibility. Civilian and military lines are not erased, they are blurred by design. The Houthis illustrate how that ecosystem can empower proxies. Satellite imagery provides broad maritime awareness. Chinese manufactured components feed missile and drone production. Iranian advisors contribute technical refinement. Local operators execute attacks. American forces respond tactically, intercepting missiles, conducting airstrikes, but the enabling architecture persists. Breaking this cycle requires more than kinetic force. It demands coordinated export controls with allies, clearer standards around dual-use technologies, and international agreements defining acceptable behavior in commercial space operations. It also requires recognition that future conflict may rarely resemble past wars. Instead, it may look like calibrated disruption, enough violence to impose cost, not enough to trigger global war. To understand the stakes, consider how dramatically the Houthis' capabilities have evolved. A decade ago, their arsenal largely consisted of aging Soviet-era missiles and improvised rockets. Accuracy was limited, range was constrained, drones were rudimentary. Today, their inventory includes a long-range UAVs capable of striking across regions, anti-ship ballistic missiles derived from Iranian designs, and cruise missiles with extended reach. That transformation did not happen organically. It required materials, electronics, propulsion systems, guidance modules, and, critically, intelligence. Imagine a layered targeting sequence. First, wide-area satellite imagery identifies general maritime patterns, patrol zones, transit routes, vessel types. Analysts, likely operating through Iranian channels, refine that data into actionable intelligence. Not live missile guidance, but operational awareness. Next, local reconnaissance drones confirm presence. Small UAVs loiter, providing real-time video and refining target positioning. Finally, a strike package launches. Drones may be sent first to trigger defensive systems and expend interceptors. Then higher value missiles follow, exploiting reduced defensive capacity. The mathematics favor the attacker. A relatively inexpensive drone forces the defender to expend a multi-million-dollar interceptor. Repeat enough times, and even successful defenses impose strategic cost. Without it, attacks become guesswork. With it, they become calculated risk. The supply chain sustaining this capability is equally sophisticated. Procurement often begins with seemingly benign purchases. Flight controllers, navigation chips, communication modules, ordered through commercial platforms. These components move through global logistics hubs, sometimes directly, sometimes via intermediary ports. By the time they arrive in Yemen, they are indistinguishable from legitimate civilian cargo. Interdictions have occurred. Naval patrols have seized shipments of missile parts and UAV components, but every intercepted shipment implies others that passed unnoticed. Moreover, adaptation has followed enforcement. Instead of importing complete systems, the network shifted toward modular components. Instead of relying entirely on external assembly, local production increased. United Nations investigators have documented evidence of domestic weapon assembly using imported parts. In modern conflict, resilience lies not in stockpiles, but in networks. If knowledge, components, and intelligence continue flowing, capability regenerates. The Red Sea crisis is therefore not only about maritime security, it is about the convergence of commercial space infrastructure, globalized supply chains, and proxy warfare. Satellites orbit above, collecting data. Factories produce dual-use technology. Militias integrate both into operational strategy. No formal alliance binds these actors publicly. And perhaps the most unsettling part is this: the system does not require overt coordination at every step. It functions because incentives overlap. China gains leverage without direct confrontation. Iran expands proxy reach. The Houthis elevate their strategic relevance. Meanwhile, American forces operate in a perpetual cycle of defense and retaliation, confronting symptoms while the enabling architecture remains largely intact. This may be the template for a future conflict, not world wars of mass mobilization, but persistent competition conducted through data streams, export manifests, satellite passes, and deniable intermediaries. And as more satellites launch, as production lines accelerate, and as dual-use technologies become ever more accessible, the boundary between civilian infrastructure and military advantage grows thinner. The Red Sea is not an isolated episode. It may be a glimpse of what 21st century rivalry looks like when power is projected not just through fleets and armies, but through orbiting sensors, commercial supply chains, and carefully calibrated ambiguity. The involvement of Chinese firms in this network did not begin at its current scale. In the early stages of the Yemen conflict, most weapons and materials reaching the Houthis were either transferred directly from Iran or sourced from captured Yemeni military stockpiles. Chinese-made items appeared occasionally, but they represented a relatively small share of the total flow. That balance shifted dramatically in the early 2020s. Between 2021 and 2025, documented weapons-related components linked to Chinese origin rose sharply, accounting for roughly a third of identified shipments destined for Houthi-linked networks. That is not a marginal increase. It reflects a structural change in sourcing patterns. Whether driven by commercial opportunism, strategic alignment, or a combination of both, multiple Chinese entities became far more visible in the supply chain. Some analysts argue that profit incentives alone explain this expansion. In a globalized electronics market, companies sell to intermediaries with limited oversight of final users. But the scale of the shift, combined with the highly specialized nature of certain components, makes the purely commercial explanation incomplete at best. Consider several cases cited in U.S. Treasury designations. Shenzhen Rayon Technology reportedly exported advanced components with clear applicability in missile guidance systems. These were not generic consumer parts. They were specialized devices frequently associated with precision weapon assembly. Shenzhen Boyu Imports and Exports allegedly facilitated shipments of dual-use equipment through its logistics channels. Sanctions imposed on these companies were not described as precautionary. They were presented as responses to documented transactions, shipment records, and intelligence assessments connecting components to operational use. Yet enforcement has proven reactive rather than preventive. As certain firms are blacklisted, others emerge. Distribution routes adjust. Intermediaries shift. The flow adapts. This dynamic raises uncomfortable questions about international enforcement mechanisms. United Nations Security Council resolutions impose an arms embargo on the Houthis. Member states are obligated to prevent weapons and related materials from reaching them. China, as a permanent Security Council member, voted in favor of those measures. At the same time, Chinese origin components continue appearing in interdicted shipments and investigative reports. When pressed, Chinese officials typically emphasize 3 points. Dual-use technology is inherently difficult to regulate. Private firms operate with some autonomy, and evidence linking specific exports to specific end users can be inconclusive. All of those arguments contain elements of truth. Dual-use oversight is genuinely complex. Commercial supply chains span dozens of jurisdictions. Components often change hands multiple times before final assembly. But regulatory difficulty does not equate to regulatory impossibility. China possesses extensive domestic surveillance capabilities, centralized industrial oversight structures, and robust customs enforcement systems. If Beijing made the elimination of this trade a strategic priority, it has the tools to tighten controls significantly. The persistence, and in some cases growth, of the component flow suggests that other policy objectives may be taking precedence. Satellite support exists in an even more ambiguous legal space. Selling satellite imagery is not automatically unlawful. Commercial space firms routinely provide Earth observation data to governments, corporations, and research institutions worldwide. The legal question becomes one of awareness and intent. If a company knows, or reasonably should know, that its imagery is being used to facilitate armed attacks, liability questions begin to surface. Yet proving knowledge in an international form is extraordinarily difficult. A satellite operator can plausibly argue that it provides imagery as a neutral commercial service. Once data is sold, it may have limited visibility into how customers integrate it into broader intelligence workflows. The gap between providing imagery and directly targeting a vessel creates legal distance, and that distance is where modern strategic competition increasingly operates. Traditional laws of armed conflict were developed for identifiable armies, visible supply lines, and clearly marked military assets. They were not designed for a world in which commercial satellite constellations feed targeting databases, where precision components pass through 4 intermediaries before reaching assembly sites, and where state influence operates indirectly through corporate ecosystems. The legal framework has not fully adapted to these realities. That lag creates operational space. From Beijing's vantage point, the broader picture extends far beyond Yemen. China's long-term objective is not episodic disruption. It is gradual, systemic rebalancing of global power structures. Economically, Beijing invests in infrastructure and trade corridors through initiatives such as the Belt and Road. Diplomatically, it presents itself as an alternative pole of leadership for developing nations. Militarily, it continues a sustained modernization campaign emphasizing capabilities designed to complicate U.S. force projection. Within that larger strategy, instability in the Red Sea imposes manageable costs on Washington, while requiring limited direct Chinese exposure. Every diverted shipping route increases transit times and expenses. Every extended naval deployment strains U.S. readiness cycles. Every unresolved maritime threat introduces uncertainty into global logistics networks traditionally underwritten by American security guarantees. None of these outcomes alone alters the balance of power, but strategic competition often unfolds through cumulative pressure rather than singular, decisive blows. There is also a technological learning dimension. China has invested heavily in anti-access and area denial systems, including long-range anti-ship ballistic missiles intended to threaten high-value naval assets. While these systems have been tested extensively, real-world combat data against advanced naval defenses is rare. Engagements in the Red Sea, where U.S. and allied forces intercept drones and missiles under operational conditions, generate observable outcomes. Which defensive systems activate first? How quickly are interceptors deployed? What are engagement ranges and success rates? How do layered defenses perform under saturation attempts? Open source reporting alone provides insights. Classified monitoring would yield more. For military planners, such data has immense value. It informs modeling, simulation, and doctrine refinement in ways that peacetime exercises cannot fully replicate. Meanwhile, the Houthis refine their own tactics. Early in the conflict, their arsenal relied heavily on older missile stocks and relatively unsophisticated drones. Over time, capabilities expanded to include longer-range UAVs, anti-ship ballistic systems derived from Iranian designs, and increasingly coordinated attack sequences. A typical engagement might involve layered actions. Initial drone waves to trigger defensive responses, followed by higher-value missile launches exploiting any defensive depletion. From a cost perspective, inexpensive drones forcing multi-million-dollar interceptors create asymmetry that favors the attacker, even when defenses succeed. Sustained surveillance, whether from satellites or other intelligence sources, enhances the precision and timing of such operations. Without it, attacks revert to probabilistic strikes. With it, they become calculated gambles. Looking ahead, the current equilibrium appears unstable. One pathway is escalation. Washington could broaden its response, expanding interdictions, targeting upstream logistical nodes, or even addressing supporting infrastructure beyond Yemen. Each step increases the risk of regional spillover or unintended confrontation. Another pathway is strategic adjustment. The United States might recalibrate its posture, concentrating on protecting core national interests while encouraging greater burden sharing from allies whose trade depends heavily on Red Sea transit. A third path involves diplomatic de-escalation linked to wider regional dynamics. If underlying tensions connected to other Middle Eastern conflicts ease, the intensity of maritime attacks could diminish, though proxy incentives would likely remain. A fourth approach centers on technology. Cheaper defensive systems, including directed energy weapons and advanced autonomous tracking tools, could alter the cost equation. Enhanced supply chain monitoring and coordinated export enforcement might reduce component flow. None of these measures are decisive individually, but collectively, they could narrow the asymmetry. Ultimately, Beijing's calculus will shift only if perceived costs outweigh perceived gains. At present, the strategic advantages, incremental pressure on U.S. operations, valuable observational data, limited direct exposure, appear to exceed diplomatic friction from sanctions and criticism. Whether that equation changes depends on how other major powers respond. What is clear is that the Red Sea is not merely a localized crisis. It is a proving ground for 21st century competition, conducted below the threshold of declared war. Commercial supply chains, private technology firms, satellite constellations, proxy militias, and great power rivalry intersect in a single maritime corridor. Future conflicts may not begin with formal declarations or conventional invasions. They may unfold through deniable assistance, economic leverage, digital infrastructure, and precision components moving quietly through global trade routes. In that sense, the Red Sea is less an anomaly and more a preview. The boundaries between civilian and military, public and private, peace and conflict are becoming progressively harder to distinguish. Strategic advantage increasingly flows to those who can operate within that ambiguity, shaping outcomes while maintaining plausible distance from the battlefield itself.